Masterclass video 3, variable vertical forces. The thing to remember here is if the particle is projected up, there'll be a resistance to its motion downwards, and if the particle is falling downwards, there'll be a resistance to its motion upwards. The weight, however, will always act vertically down and is given by m multiplied by acceleration due to gravity, which is a constant. Okay, these questions are in the Google Drive folder that I shared with you already. So it's 15F, question 1. Let's read the question. A particle of mass m is projected vertically upwards. If it's projected vertically upwards, there'll be a resistance downwards and a weight downwards. All right, we keep going. An initial speed of 4g meters per second. So the speed is 4g when the time is 0 and probably also when the displacement is equal to 0. If we keep reading, in a medium where the resistance to its motion is that, great. So that means I have two forces downwards, mkv squared plus mg. The rest of the sentence there is just describing each of the terms. Part 1. Find in terms of k the maximum height reached by the particle. Here I'm thinking straight away, draw a diagram. I'm going to assume that the particle, its velocity goes to 0 at the maximum height. And we're going to get the displacement when v is equal to 0. I've already stated the initial conditions. Okay, so look at the diagram. So what we have is the particle going upwards. Because we haven't been told anything about its acceleration, we're going to assume that it's accelerating upwards, just because it's travelling upwards. That's the convention. Now, whichever way it's travelling, initially we assume that that's the positive direction. So if that's positive, mg and mkv squared are downwards, so they have to be negative. And that brings us to the second line in the solution. Minus mg minus mkv squared equals ma. The m's cancel. So what we then need to do is rearrange it, get all the v's and dv's on one side, the s's and ds's on the other side. And that brings me to the fourth line, the integral, which is v over g plus kv squared, all integrated with respect to dv. And the right hand side minus the integral of ds. Now the right hand side is straightforward. The left hand side you'll use a substitution. So let u equal to g plus kv squared, and then differentiate it. And when you differentiate it, make the substitutions and then integrate it in its relatively straightforward form. You'll get the next line, the natural log of g plus kv squared all over 2k is equal to minus s plus c. Sub in your initial conditions. X or s is equal to 0 when the velocity is 4g. That will give you a constant of integration. And then you're just looking to simplify that and make h the subject of the equation, which brings us to the last step. Right, let's go on to part 2. So if the speed of the particle is 2g when it's at half at the maximum height, find the value of k. Again, we're given a speed and a distance. Now we're looking for a k value. So it should be relatively straightforward. We take the formula we had already after integration. So that was natural log of g plus kv squared over 2k is equal to s plus c. Put in your initial conditions, get a c value, and then you just want to make a substitution there. The speed of the particle v is 2g. The height that it's half the maximum height at, you just put in the thing found in part 1 over 2, so you're dividing what you found in part 1 by 2, and then you find your k value, 1 over 2g. Okay, next question. Question 4. So pause the video, have a go off it. I'm going